Hi, welcome to this video. In this video I'm going to explain the functionality of the Cat Repellent version 2 that I built, which is programmed with the YAL programming language. So what will be the contents of this video? First, why I did this project. Then the feature of the Cat Repellent version 2 and what version 2 is all about. Something about the half-bridge mode that I'm using to control the piezo buzzers. Then something about the piezo driver circuits that I investigated and the one that I'm using. The schematic diagram of this Cat Repellent. The hardware as I build it on a breadboard and also how I build it in a cabinet. Something about the software. Of course a demonstration video. And at the end of this video you can find some references. So why did I do this project? In the past I had made a battery powered cat repellent and you can watch the other video about this project. But there was a cat sitting outside of the range of that cat repellent. But luckily at that location I have a mains outlet and that gives extra possibilities. Because now I built a cat repellent that is continuously active because I have mains power. So what are the features of this cat repellent? As I said, it's mains powered and it will send a tone of 40 kilohertz, but it will be 500 milliseconds on and 500 milliseconds off, and I'm using two piezo buzzers. I'm also using a passive infrared receiver because I want to detect movement, and this receiver is powered by 5 volts just as the rest of the electronics, but it operates at 3.3 volts, which is okay. And when movement is detected, two things will happen for 1 minute. The piezo buzzer frequency changes. The tone will be 40 kHz of course, but it will be 100 milliseconds on and 100 milliseconds off. And a white LED will start blinking with the same frequency. And this continues as long as there is movement. So some information about driving a piezo buzzer. You should prevent a DC component, so there should not be any DC components when driving a piezo buzzer. And if you use a half-bridge mode signal, you can double the output of the buzzer and also so the range of the buzzer. And half-bridge mode signal means that you have two pins. When one pin goes high, the other pin goes low. And the PIC microcontroller can generate such a half-bridge mode signal. And I investigated two options for driving the piezo buzzers. So driver circuit option 1 is using a simple capacitor. And the driving power then comes from the PIC microcontroller. And this circuit looks like this. So just two piezo buzzer and one capacitor. This is then the output of the PIC microcontroller, and you can see the signal is a little bit distorted because it's driving the piezo buzzers. And here you see the half bridge mode, so one signal goes up, the other signal goes down. And this is then the signal on the piezo buzzers themselves. And as you can see, the peak voltage is now 10 volts instead of 5. If you look at driver circuit option 2, I'm using transistors. I also need pull-up resistors, which are used to disable the circuit. I will explain that later in this presentation. So the circuit then looks like this. And the signal on the PIC is then much cleaner. And the driving signal looks like this. And the strange waveform is caused by the fact that the transistors are partly on, and at some moment they are both very on for a very short time. And as you can see, the peak voltage is again 10 volts. And as I said, there should be no DC component on the piezo buzzer, which is true for both the circuits. So if you look at the signal, when it's off, there is no DC component, and when it's on, it's plus 5 volt and minus 5 volt, so 10 volt peak. The schematic diagram that I'm using looks as follows. So as you can see, there is the PIC microcontroller. I have this passive infrared module which is connected to the PIC. Then the driver circuit using the transistors and the piezo buzzers. And the pull-up resistors, which are important. So the hardware was built on a breadboard. So it starts with the mains connection, then I'm using a fuse for safety, which is then connected to the power supply. I'm using here the PIC microcontroller. I have the connection for the passive infrared receiver, also the connection for the LED, which I did not mention in the schematic diagram, but it's there, and the driver circuit where you can connect the buzzers to. And if you build it in the cabinet, it looks like this. So at the bottom you see the passive infrared module, and in the middle of the two buzzers there is the LED. So the PIC is configured to run on an internal clock of 4 MHz, which is sufficient for this application. And I'm using the pulse width modulation hardware of the PIC microcontroller to generate a 40 kHz signal, and a timer is used for that. And the main loop is quite simple. It pulls the input pin to which the passive infrared receiver is connected. And when there's no 40 kHz signal present, then both the pins, output pins of the PIC microcontroller are set to input. And because of the pull-up resistors, this will make sure that the driver circuit becomes inactive and there's no DC component. And the whole program is quite small. It uses 151 bytes of ROM and 10 bytes of RAM, which fits easily in this PIC microcontroller. In the demonstration video you will see the following. I'm using a breadboard with some electronics to which I have connected a piezo receiver so that I can make the 40 kHz signal visible. And in the video that is the breadboard which is lying in front of the Cat Repellent. But normally the Cat Repellent is continuously producing this 40 kHz signal, which is 500 milliseconds on and 500 milliseconds off. And then there is some movement that you will see, and then the LED will blink and the signal changes to 100 milliseconds on and 100 milliseconds off. And also the LED will change and will blink with that same repetition rate. If you want to know more about YAL in the YAL programming language, you can visit the YAL website. There you can download the YAL packages, which contains the libraries, the sample files and the YAL compiler. And if you want to get started with YAL, you can have a look at this video. If you have questions on how to use YAL, there's a very good YAL tutorial that you can download from the website, but it's also present in the installation package. And you can also post your question on the YAL Google group. And if you find bugs in libraries or in the compiler or you have specific requests, you can visit the YALDIB Google group. I hope you liked this video, and thanks for watching.